Good afternoon in the UK, and good morning in the US, and good day for the rest of the world. My name is Steve Cowles. I'm your host for today's episode of Tech Talk with Steve. Episode 26, we're going to be talking about smart test solutions for smart buildings. You hear us talk about that a lot. I've got a special guest with me here today, James Vian. James has over 22 years of experience in integrated security and safety systems from design, tender, installation, commissioning, and verification. He has built up a wealth of experience within the contract chain in many verticals. An early adopter of converged technology, the use of the LAN as the vital connective backbone of these projects, he recognizes the importance of testing and benchmarking installations as a prerequisite for reliability and total low cost of ownership. His current role is that of technical and training manager at Mayflex, which allows him to share his experience and knowledge and passion with the complementary disciplines of infrastructure, safety, and security. Welcome, James. It's good to have you here.
Good afternoon. Welcome to Mayflex.
Thank you very much.
Great to be with you.
Great. So you've probably seen when we advertised on LinkedIn and other social media that we are coming to you live from the UK. We're at the Mayflex headquarters in Birmingham, UK. And for those of you in the US, that is the correct pronunciation. It's not Birmingham, it's Birmingham. So I'm sure James will appreciate that. So James, dive into the smart building test. Tell us a little bit about Mayflex, what you do, some of the different verticals that you're engaged in, and the things that you do beyond distribution.
Okay, so for those of you that don't know Mayflex, you may know our brands of Excel and Vian. So we're a manufacturer of those as well as a distributor of infrastructure and, say, security products as well. So we get very much involved with projects around the UK and other parts of the world as well. So the Excel brand is over, I think it's 80 countries now. We're part of Sonopar, which is probably the largest company that you may never have heard of. So we've got a global reach, which is really great for our products. Now, a lot of the projects that we get involved in are new build, so things like hospitals, things like student accommodation, education, government, all that kind of things, in addition to all of the kind of the commercial stuff that you would expect.
Great, fantastic. Sounds like you're into so many different things, and I guess that kind of plays into our topic today. We're talking about smart buildings because it encompasses so many more things than what we're used to in the traditional LAN environment. So I'm going to go ahead and share my screen because I do want to show a couple of things here, and we'll just go through this real quick. And we promise this won't be death by PowerPoint. Just want to make a couple of good points. We talk about the Internet of Things. This is impacting everything, not just our homes. It impacts our workplaces, our commercial buildings. Internet of Things is more than just our tablets and laptops. It's also things like our building control systems, occupancy sensors, lighting controls, the lighting itself. Those kind of things are all connected now. And as this changes, way back when I first got into this, even before we had cabling categories, everything was separate. All these systems were disparate in the building. So you had one cabling system for your security systems, one for your fire alarm, one for your video cameras, everything else. So now it's all coming together. And back then, we had Cat 3, we had Cat 5, Cat 4 kind of came and went in between those. And now we see everything coming together under that same network. So the building systems are all tied together in the network. They all interact. You can walk into a building, you swipe your key card, and it knows who you are. It knows the office where you're destined to go sit and work on your computer. So the lighting comes on in the different corridors that you might have to travel through. The heating and cooling comes on to the appropriate temperatures in the areas where you're going to travel. All these kind of things now tie into the network. Because of that, we now have to consider a lot of different things when it comes to testing. So we're looking at, not just, the building itself is changing, but the testing has to change. We can no longer rely on just certifying the cable. Yes, it's a very important thing to do, and we should do it for any commercial installation. But you need to go beyond that, because once the cabling has been connected to the various devices and you've got your switches and everything in place, it's good to be able to understand what you can get out of that network. And this is a good snapshot of a typical smart building infrastructure. We see a 2,312 square meter building here, and you can look at all these different devices. So you've got all these, over 300, almost 400 LED lights. You've got phones, you've got monitors, you've got large displays in conference rooms, shade controls for the windows, all these things, and the access controls, they all add up. And you look at this, we've got, over 750 devices here that are relying on this smart infrastructure. And a lot of them are PoE in this case. So it gives us a lot to think about. What do we want out of the building? What's the network environment? Do we have power? Does everything need to be power? Only some things need to be power. What level of power do they need? So these are all things we need to consider. And this is kind of a good snapshot. If we look at this chart on the left side, you'll see the typical cable certification test parameters, things like length, delay skew, your loop resistance, crosstalk, those type of things. And then there's some supplemental tests that add DC resistance unbalance within the pair or pair-to-pair as a pre-qualifier for power over Ethernet. It's not a PoE test. It is a pre-qualifier that the cabling should support PoE. And then TCL and ELTCTL let you know that your cable is in good shape regarding noise resistance. And then some additional parameters, physical troubleshooting parameters, TDR traces to find the problems if you fail return loss or crosstalk, for instance, or you have a shield issue. And then when we go beyond that, when we start getting into smart buildings, is where we really have to step up our game when it comes to testing. And we're looking at things like doing multi-gigabit Ethernet testing with signal to noise ratio. So we know that once the network's deployed, we don't have excessive noise. Things like PoE load testing, being able to look at the network and tell what devices are attached. Can I get to the internet? Can I know what switch port I'm connected to? So these are all things that we need to consider when we're talking about smart buildings. It's no longer just a certification test. So now I'm going to go close this down and go back to camera here. And we'll, so keeping some of these things in mind, what type of things are you encountering, and you in your technical support role, and even in your previous roles, because you've had so much experience on the install side of this? What are some of the things that you're seeing that make you see the value, perhaps, of going beyond just that cable test? And are you seeing where is it just at the installation, right after installation, or throughout the life of the cabling?
Oh, it's everything. The big keyword at the moment is future proofing. Mm-hmm. Now we can't foresee the future, but we can predict the way that it's going to go. Excuse me. So we're starting to see, gigabit throughout is pretty much common. Maybe less so on the security camera side. We don't need those kind of link between the switch and the camera to be gigabit. Compression technologies are good, so we're making good use of that network there. But actually, it's those interconnects between the CCTV system and maybe the home automation system, or whether we're linking it up to the cloud for whether we're getting AI involved with trying to decide whether a person or an object poses a threat. That's the way we're kind of going. So we need that proper connectivity, and that proper connectivity coming in to maybe a project that might be 5 or 6 years old. And we wouldn't have predicted it would be getting gigabit fiber to the home as freely as we are already. Right. Even I live in a village and we've got gigabit to the home available. And according to the technicians there, that'll run 10 gig. So, the public switch networks are thinking about it already. And I think we've kind of been a little bit behind. There's a few people, there's a growing movement that are really looking towards making things future-proof in the home. And the future is not just fiber. We kind of predicted maybe 5 years ago that the number of copper points that you get in a dwelling or a business were going to drop because everybody was going Wi-Fi. Well, now actually it's kind of gone the other way around. We're starting to see more and more points in a building, but they may not be mounted on the desk as they would have been traditionally. So, you might get fiber to the desk, but equally you've got a data point there that could be providing power to power your laptop. The screen that's behind me here could be powered by PoE, and we've got to have that infrastructure because it gives us choices. Now, from an installer's perspective, I think the most important thing about testing, I think this is the thing that people forget, is after your first fix, test your cables. Because if you've proven that you've done your work there and it gets damaged once the ceilings have been closed up, once everything's put away neatly, then you've got to start doing a lot of remedial works to kind of correct those. And then I've lost count of the number of times we've had to go back and open up areas that have previously been made look pretty, and we couldn't prove that we'd done our job properly
because you hadn't tested it
because
first.
we hadn't tested it first.
Yeah.
And then, I mean, the nice thing, we can print out these results, we can email these results, we can attach them to our monthly invoice as part of the ongoing project, because it proves that we've done what we've done. It means that we get paid faster, number one. And equally, if somebody else damages our cables, maybe it gets snagged by a plasterer or drywall guy, means that we can then charge to go back and put that right.
That makes absolute sense. And I think it extends beyond the cable test itself, because when we think about, you've tested the cable was good. The other thing that you can do with a tester that's capable of going beyond that, doing the multi-gig Ethernet testing or PoE testing, you can actually test after all of the network gear is installed, run your testing on that as well. Two things you can do with that. You can provide it as a value add to the end user of additional testing, showing them, yes, I can get this level of PoE. I can get 5 gig or 2.5 gig on each of these wireless access point runs, and provide that as part of their printed report documentation. But aside from providing that additional service for the end customer, as a contractor, it gives you that additional, we call it cover your rear. You've actually you've documented that, yes, I had 2.5 gig, everything was fine, and all of a sudden that customer calls and says, hey, I'm having a problem. It costs money to roll a work van or a truck to the job site to troubleshoot something. Probably a minimum 150, 200 pounds. It's going to cost you to just send a technician out to troubleshoot that. If you've documented it was working prior, and you come back in and you start doing the same testing and troubleshooting, using these type of tools, you can narrow down, for instance, if they replaced a patch cord on a PoE, between a PoE switch and the patch panel. They moved something, they lost a patch cord, and they went down to the local convenience store and just bought a really cheap patch cord and plug it in. It's going to cause a problem for the PoE. Yeah. And you can prove with this type of testing, yeah, here's where your problem is. This is why it's happened. It was working when we left. We're now going to charge you for this service call. It's not going to be a free service call. So,
and actually that kind of service call is more profitable, because you're actually proving that somebody else has done something to the system, so you can charge a higher rate. And actually, it might take you half the time to find that fault, but you can still charge the same amount or more, because you've got a higher skill level, higher provision of equipment to do that.
Exactly. And then you document it again. Once you've corrected the problem, you again, to your point, document it. Something else that I've seen come up of late that seems to be talked about more and more is legacy cable systems you've got in a building. You want to find out, can I run a specific type of network over it? You can do application-based testing. You can, maybe it was certified to 5E or Cat 6, and you want to see, okay, can I run my PoE over it? Things that you can do with smart building testers, you can add a PoE injector, have a main and a remote smart building tester, and you can run a 10 gig test with PoE load on there. And you can determine, can this length of cable support this? Will I be able to run this, or am I going to have a problem with it? So that helps an end user, a building owner, maybe determine that should I keep my installed cabling, or does it make more sense to go ahead and replace it? And it really depends on what they're going to run over it.
Absolutely. A perfect example, as a contractor, we would install a large number of Cat 5e, then Cat 6, now Cat 6a cables behind, say, a TV, the main media center point within the dwelling, or multiples of them. And now, we didn't know what was coming. So now we can go back and test it and see whether that cabling is going to work. Exactly. And that, nowadays, just a customer of ours I'm very friendly with, talking the other day, that they've done the install of the smart home, the original connected media, maybe 6-7 years ago. They've then, customers then gone, well, actually, I've got a new 4K TV box. I want to be able to stream that across the cabling that I've got. Can I do it with what I've got, or do I have to get you guys to come and drag in some very expensive HDMI cables?
Exactly.
So the new box goes in the comms room, and they were able to check to see whether that cabling, thankfully, It's good quality
That's
cabling.
Yeah, that's
And they're
great.
able to stream it over there. Because if you've got to compress the 4K video to get it over a Cat5e or a lower grade Cat6 cable, maybe it's not been terminated properly or treated properly or kept segregated from mains, then if you can test it and prove it's going to work, it means that you don't have to start getting the saw out and making holes in the customer's wall.
Exactly. So with some of this, you think about it, we kind of, we're looking at the testing. We always think about testing at installation. You install the cabling, you've tested it at the installation point, but then you need to go and do more beyond that. You're doing these additional tests. So you're really looking at testing solutions that go from the installation of the cable through the implementation of the technology. So whether it's wireless access point technology, or it's a PoE extender, or a smart TV device, or whatever it is, you're able to encompass that from the time you install the cabling through the implementation of new technologies as the technologies change. And kind of thinking about as technologies changed, we were talking a little earlier before going live here, we were talking a little bit about industrial Ethernet and single pair Ethernet and things like that. When we start talking about smart buildings, that's starting to become more of the buzzword, the single pair Ethernet, building controllers and things like that. It's not necessarily going to take the place of your LAN, because it's designed for low speed and longer distances, and also to be able to provide power for those, like the cameras that don't require as much speed, or the occupancy sensors or security sensors, things like that. So it's important when you're thinking about your smart building test solution to consider single pair Ethernet as one of those technologies that you're going to need to be ready for, because it's
the commercial space as well.
Yes, exactly. And it's and the SPE does a few things. The cable's a smaller diameter. It's going to take up less space. It allows you to take those slower, less bandwidth hungry devices and offload them from your main network. So you're able to kind of shift that. So it's important to be able to test that as well, because anything we install, certainly we want to make sure that we test it and then be able to support that technology throughout the life of that cabling plan. And now Mayflex are involved in industrial applications like that as well, correct?
Yeah, so our sister company Rutico, based in Milton Keynes. So industrial automation is that what they do.
Gotcha.
So single pair Ethernet and all of the various things like SCADA devices are all there, and people are trying to get them onto the LAN.
Okay.
So maybe you've got legacy cabling in there for whatever was there before. If it was maybe RS485, sometimes we can repurpose those cables to give you effectively single pair Ethernet.
Right.
So it's good crossover there.
Yeah. So something else that kind of dawned on me here, and we've talked about this in a previous conversation, is there are some acronyms that are used when we talk like copper clad aluminum cable.
Yeah,
we talked about.
We were talking about this. So, there's a bit of a name collision with that.
Yeah. So for anybody who's not aware, sometimes when you get some cabling construction of twisted pair cabling, it should be a copper twisted pair. But there are some cables out there that are copper clad aluminum, and in the U.S. we refer to it as CCA. That has a whole different meaning.
Yeah.
Over here. So those kind of cabling designs can cause issues for power over Ethernet. When we talked about DC resistance unbalance, that's particularly where it starts to become a problem, and it can cause issues with PoE. And if you have an unbalance issue, your cabling can heat up, your PoE devices don't work properly, your network may have trouble. So now the CCA that you're referring to is something different. What is that?
Yeah, so it's with regards to the cabling standards. So we still talk about CCA being copper clad aluminium, but there's also a Euroclass CCA, which is about its resistance to and the propagation of fire, whether it produces like fumes if it catches fire, how much the flame's going to propagate against its length, whether you're going to get acid droplets from there. So it's about safety of the cable. It's not about fireproofing the cable. It's about safety of the environment that cable's in there.
The burn rate of the cable and the release of toxins. So in the U.S. market, we see things like CMR ratings and CL2, those kind of things, CMP type ratings. So
yeah,
similar. It's the fire rating of the cable essentially.
It's kind of a bit like where you've got a plenum space and you have to put a plenum rated cable in there, we have to do the same. So anything that's fixed cable.
Okay. So if they see CCA on the jacket material, it's likely safety related, not related to the conductors.
So what you might find is what you should see on the cable. So it should be marked on there to get your CE rating, and then you'll have a long string of characters. Only one of them might be CCA.
Okay.
So this is to do with the British Standard 670 or BS 6701, which was amended in 2017. So we always put all the details on the cable, so you can never get it wrong.
Gotcha.
But when you look at it, and you might find an advert online or a catalog from somebody, it might say CCA. Now, does that mean that it is a Euroclass CCA? In which case, it's a good quality cable. It's going to give you kind of low smoke. It's going to be suitable for install in new installs now in the UK. Or is it copper clad aluminium, a domestic grade cable, which might be good for some things up to maybe 60, 70 meters. What's that, 150 feet, something like that?
100 meters is 328 feet. So.
Around 150 feet, 100 to 200 feet.
You're making me do math a lot.
Yeah, I did the same here. It's never my strongest point. So, we should qualify really that some copper clad aluminium, some copper clad steel cables for their application, maybe a coaxial based underground cable or a power cable, absolutely perfect for that, but that's not what we're talking about with data.
Right.
So data, pure copper is exactly what we want.
Now you mentioned when we put the markings on the cable, Mayflex make their own cable and infrastructure products as well, correct?
We do, yeah. So we mark all of those. It's part of the declaration of performance. So on the box, you get a little label. On the cable, all of the details, including that declaration of performance test number. It's all third-party tested in country as well, so it has to be done in the UK. So if you want to verify whether the cable meets the standard and meets the requirements assessed for the job, so you can take that DOP number, pop it into the website, and you can pull up the original declaration of performance for that cable.
Perfect.
So you would end up with a proper classification of what it can and can't do and what it's designed to do.
Excellent. And then all those products are under the XL brand, correct?
Yes.
Okay. And that includes cabling, connectors, racks,
fiber,
pre-made terminations, fiber.
Yeah.
So the whole gamut.
Yeah.
So you're doing it all. That's
absolutely
fantastic. Yeah. Fantastic.
We've got some fantastic projects out there at the moment that combine all of our strengths. So we have something like 21% market share with the XL brand in the UK. So we've got the infrastructure products and then the cabinets to house them, and then we can also bolt on the security products, the CCTV, the access control, which are third-party products for us, but we include them as part of that.
Right.
Which gives you the contractor the ability to kind of blend the margins from a lower margin data installation, higher margin CCTV or access control installation, and own the whole share of wallet.
Right.
And one tester that does the lot.
Exactly. So, and it's interesting because I see, in your building here, I see a lot of smart building technology that's deployed. Have you noticed in the post-COVID era, if we can call it that, that you're seeing more commercial buildings upgrading their systems like this? Because as employees are starting to come back to work, they're realizing that the technology they've got really needs to be beefed up a little bit. Are you seeing like an upsurge in these new technologies being rolled out?
Absolutely, and it's the flexibility as well.
Right.
So, yesterday when I was in here, there was maybe 30 people upstairs in the office. Nobody owns a desk anymore. So if you want a desk, you book your desk on the app. So you've got all your connectivity; it's all there for you. And I guess it's going to turn the heating and cooling on when people start to arrive, which is exactly what we want. But today there's maybe 90 or 100 people upstairs, so there's going to be some different requirements, but the systems know all of this,
right? Which
is really clever. So sustainability and environmental responsibility is kind of built into what we do.
It's all dynamic. It adjusts on the fly. Yeah. So that's...
I've been in buildings in London for some of our vendor partners where it literally doesn't turn the lights on until you walk into the building.
Wow.
Yeah, it's tracking your phone. You use your phone to swipe in using your mobile access control that's been granted to you for that day. You get an email. You click on the email. It adds your credentials for your access control to your phone for that day, and once you enter the building, once you get onto the floor, it'll turn the lights on in your area and enable the desk for you.
So only using the energy that you need.
Yeah.
And that's, going back to the whole sustainability. And that kind of, it dovetails in with what the testers will do when you're looking at your cabling plant. We mentioned resistance earlier, and one of the byproducts of having a resistance issue with the cabling is the cabling heating up. That can in fact impact your building climate control systems as well, because then they have to compensate for what's happening with the cabling.
More AC.
Exactly. So it all kind of ties in together. So, having the system designed properly, having the right test equipment to go from that, as I mentioned earlier, the installation to implementation is going to be key in making sure that, not just is your design solid and it's going to be a sustainable design and have less of an impact on the environment, but that you continue to have less of an impact as your cable plant ages. You can make sure that, yes, this is still going to support what we need, and it's not going to contribute to any environmental issues. So
yeah, that's kind of important. That's what we do. We've kind of gone plastic-free packaging, try to eliminate all the single-use plastic. We've got proper cardboard boxes rather than a plastic box.
Right. Well,
and it works in twofold as well, because as an engineer, if I get a box of Keystone jacks to make the ends off on my cables, they come in a box of 24 rather than 25 plastic bags.
Mm-hmm.
And that appeals to me.
Yeah.
Because I've still got fingers before I start.
Right. Exactly.
And it's faster.
Yeah. And you're thinking about that, all this talk about sustainability and the impact on the environment. We need to be good stewards of the planet. We've only got one. So, so we don't want to mess it up. Right. So it's good to take care of it. So
I think the other thing that with a real trend that I've seen growing over the last 3 or 4 years has been putting things on display. So we're in a lovely bit here where everything's open and on display. But when you go into customers' premises, they want all those cable bundles on the containment nice and neat and tidy, segregated, maybe color coordinated, a bit of rainbow spaghetti in there. It's kind of, if you haven't done your cable calculations, or you haven't got the right type of cable, you haven't tested it properly, if you put too much power down your cable, you're at risk of compromising that bundle of, say, 24
Exactly.
cables.
Yeah. And people don't think about that. And that in the reality, when you've got a bundle of cable like that, heating becomes a much, much bigger problem if you have a resistance issue.
Yeah.
So, and that's why they limit how many you can put in a bundle. So it's very important. So let me look and see if we've got a couple of questions here. Pardon me for getting so close to the camera, but it's the only way I can see this. Legacy Cat 5 E cables could have 2 different NVPs between the pairs under the sheath, resulting in very poor pair-to-pair DC resistance and making the cable not suitable for delivering poor quality PoE. Yeah, so the NVP, the manufacturer specified the MVP value for the cable as a whole, for the whole 4-pair cable. What happens is, in the difference between the pairs, it's not as much the NVP as it is the resistance that's causing the issue. So when you get a resistance unbalance, especially on a 4-pair PoE, you've got 2 pairs sending power one direction, 2 pairs sending power another direction, and if there's an imbalance between the 2 pairs going one direction, you're not getting the appropriate power delivery on that leg. But even worse, if it's unbalanced coming back the other way, it gets a total imbalance, and that creates that issue that is mentioned here. So you definitely have to make sure. What Davey said there is that when you get that unbalance, that you're aware of what's going to happen to your network, and that's why we put these tests in there. That's why we have the DC resistance unbalance, and it will actually it will show up in not just the heating of the cable, but you'll start to see your network having issues, and what happens is that on the power source, the transformer starts to have issues, and it starts to have problems with the power delivery. So the resistance is a key important part of this, because your power drops because of the resistance. I won't go into like the engineering aspects of it and Ohm's law, and I think a lot of people who are attending probably know that. But if you have too much resistance, what happens is, if you put a voltmeter on a circuit, you can measure, say it's 12 volts. I'm getting 12 volts. My cable's fine. Well, not true. until you put a load on it, you demand the current, you really don't know. And if there's excessive resistance, you may not be getting 12 volts at that end. And you certainly aren't getting the power.
And when you start bolting on something that's not a traditional PoE device, that is basically converting the PoE into something that we want to use, 12 volts DC, for example, how is that could then affect the performance of the product? Let's say if it's a maglock that's designed to be run from power over Ethernet, you can't normally run a maglock using a twisted pair cable because you get induced AC on it from alien crosstalk. So it starts to cause us problems because they do get hot. But actually, you're starting to see devices, locking devices, smart locks or presence sensors that are designed to be running off PoE fed, but ending up as non-PoE devices.
Right.
And then that's where I think we're going to start to see more and more problems.
It's going to be key that the cabling is perfectly balanced from a resistance standpoint. And the other thing if the pairs are perfectly balanced, that's when that additional TCL and LTC-TL testing comes in, because if the pairs are not well balanced, you're going to get more noise ingress, and you'll start to see issues with that. And I think that's what one of the things that Davey's getting at there with the point about NVP. If you've got a manufacturer who doesn't control their manufacturing process, we get these low end cables that have not been put through the rigors that quality manufacturer like an XL has on the cabling. You can get impurities in the copper, and one pair may be very different from another pair, not just from the resistance value, as Davey mentioned. Your NVP, it's constructed a certain way to have it's kind of like the speed limit of the cable. That weighs into your length measurement. But that resistance, if you've got a pair that's got more copper in it than another pair, the properties of the metal are different, and you're going to start to see the same issues. So aluminum or less pure copper that has other things in it, you can start to see some of these issues.
So would you say then that's where if you're looking at something like that, where you would go for the Test Pro over the NSA, because you're going to get more detail out of that test?
So you can do, when you're looking at Test Pro versus NSA, we can do DC resistance unbalance in the NSA as well. But in the NSA, it's a pair-to-pair resistance, whereas in the Test Pro, we do both pair-to-pair and within the pair. So you can examine the resistance of the individual conductors, because both of those are going to be important. Now, typically, if you've got something that's an imbalance within a pair, it will also result in an issue of a pair-to-pair resistance unbalance, because it's the two conductors, if one of them is off, that loop resistance of that pair is going to be off. It's going to be different. So when you compare it to another pair, it's also going to be off. So you can discover it even with the NSA. You can discover some of these issues. But when we're looking, the big decider between NSA and Test Pro is going to be whether or not you are certifying the cable. So is it a brand new installation? You have to certify you're providing the warranty, especially backed up by like the XL warranty.
25-year installed warranty.
You're going to use a 25-year install warranty. You want to test that with the Test Pro, the certification. The NSA is a better product if you are in a situation where you're doing troubleshooting, moves, adds, changes, network managers, IT techs, or a contractor that's maybe doing a small job that they're not certifying. And I'm not saying that you shouldn't certify every job, because in my mind, as an RCDD, if I put my RCDD hat on, I'm going to tell you need to certify every single installation. But the reality is there are a lot of contractors who install and they just use a small wire map tester, or the basic test. You plug the computer in, it connects to the network. Oh, I'm good. My job's done. But you need more than that. and what the NSA brings to the table there is it does the same RF type test that the certifier does, but it's doing it from a single-ended perspective. It's still using the TIA 1152A test limits. So it's using the crosstalk and return loss and ACRF. Those are still part of the test suite in the NSA. But because it's single-ended, it's not certification. So the deciding factor is it a warranty job? And even if it's not a manufacturer warranty job, if you've got a scope of work spelled out by the specifier that says it shall be tested with a certifier, then you must use a certifier. You have to do that. Yep. So that's kind of the differentiator between the two.
As I think with the security installers in the UK, they've kind of all tended historically to shy away from certifying. So I'm kind of pushing them towards the NSA at the moment, because they've then got a tool that can help them in their everyday jobs to fix the things to prove that they're doing the right thing. You're finding out that actually your crimp tool is broken on the pin 1 or pin 8's not
Right.
punching down quite properly as you would like. But equally, the next stage there is that we've got guys that have taken the NSA and are using it, and then when they're finding that they've got a bigger job that they want to, as you say, cover you behind, or they want to do a high level of testing on, or that's required as part of the contract, we're then renting them a certifier.
And the nice thing is, if they've been using the NSA, they really know how to use the Test Pro already, because it's the same interface.
Yeah,
yeah.
I love that.
Yeah, and we've actually seen cases also where a contractor may buy 1, 2, 3 Test Pros, and they also might buy 1 or 2 NSAs to complement them, and they'll use those if they use the certifiers for doing the certification. But then if they get a call back on a job, or they need to go troubleshoot something for a customer, they'll deploy the NSA with one of the technicians instead of pulling one of the certifiers out of the field to do that. So
it's a lower capital cost as well, which
exactly. And the nice thing is that both the Test Pro and the NSA are smart building test systems. They're both designed with the smart building in mind, and that's we develop these with smart buildings in mind. Whereas if you look at some of what we would call a legacy tester, they were designed to certify copper cable and fiber cable, and this is what they do. They do certification. When our development team developed Test Pro and later the NSA, this is what they were thinking about. It was smart buildings. They wanted to be able to do more than just test the cable. So, and again, that's where we're headed. Everything is smart buildings now. So
yeah, value for money.
Yep, exactly.
Total cost of ownership.
Yes.
And knowing before you go plugging something in that it's actually going to work.
That's it. And that's what you depend on. As a user out there in the field, you depend on. Everything has to work. When I plug my laptop in, it needs to work. So,
yeah.
Well, I think we've got we're right. Yep, we're just past our 30 minutes, and I don't see any other questions. We have is the MVP on the box as well. Some manufacturers, Chuck Bowser, chiming in to listen to us from the U.S. here while we're live from the U.K. Chuck, some manufacturers put it on the box. Some you have to look it up in the catalog, and I don't know. Do you publish it on the boxes? Do you know? You'd have to look at the label.
I'd have to look at.
Yeah, I haven't looked at a label on a box of cable in a long time. So, but I think it would depend on the manufacturer. So
yeah, we do about 300 different types of cable, so it may vary.
So let's see. I think we have another question here. So how do we ensure the power is sufficient for the different types of PoE devices from the PoE switches? So great question. So we have something called a PoE load test on Test Pro and NSA. Typical basic PoE testers will tell you that there's PoE present. They'll tell you what the voltage is. They'll tell you what the expected current is, what we call allocated power. Example of that is on a 90-watt PoE system. The allocated power is going to be 71.3 watts. And that is a theoretical number based on a 100-meter good working length of cable. That's your channel. And the output of the PSE being at that 90-watt level. That's the 802.3 BT. You don't really know that you're going to get that power there until you demand the load. Because of the resistance of the wire, until you actually draw current through the wire, you don't know how much power you're going to get to the end. So we do a PoE load test, and you can connect either of these testers and demand that load from the switch, and it will tell you exactly how much power you're going to get to that endpoint, and that's how you'll know if it's going to support your device based on the requirements of the device and the actual PoE you're getting on that on the endpoint there. The other thing that we do, we go beyond that, and just to clarify, there are some out there who they refer to something as a PoE test. And what they're talking about is a DC resistance unbalance test. That's not a PoE test. It's a pre-qualifier for PoE. That's part of the cable system test. It's the certification test, and it does the DC resistance unbalance, the TCL, TCTL. It has been referred to by some as a PoE test. It is not. It's a pre-qualifier. So with this PoE load test, you can tell, am I getting that PoE load? Am I getting that PoE power that I need? Am I getting 71 watts at the end of my cable. Do I have what I need? The other thing we do is we go beyond that with an additional device called a PoE external load box. We can connect the PoE to the test pro or the NSA. We feed the PoE out through the banana jacks on the test adapter into this PoE load box, and we can increment our load in 15 watt increments up to 90 watts. So you can take a cable, maybe that you think, we talked earlier about using a legacy cable. Take a cable that you want to find out, is it going to support 60 watts? You can set up this external load test, set it for 60 watts, and let it run. Let it sit for several hours. And it's going to build a log inside the unit, and you'll get a CSV report that'll show you over that several hours what your signal to noise ratio was on the Ethernet. It's going to show you what your PoE level was. So you'll be able to see over time, did I start to see this degrade? Did my signal to noise level start to dip? Did that ratio start to come down, getting closer to zero? Did my power fluctuate? So you can actually do something even beyond the initial PoE load test with the handset. So good question.
I guess we could also use that for testing the switch as well.
Yes, because you're testing it into the switch. So you're getting the PoE from the switch, and then you're just putting it under a continuous load. So that'll let you know if you can keep getting that load from the switch. And the PoE load test is a good tool for troubleshooting as well, because in an example like this, where you want to find out, can I get PoE load at the endpoint? When you test it, can I get that power level? You look at it and, oh, I'm not getting the power I need. You go back into the wiring closet and test directly into the switch port. Maybe it was a customer provided switch. They bought a 90 watt 12 port PoE switch off of Amazon for 60 pounds. Well, it's not going to
possibly go.
Yeah. It's going to be 90 watts, but it's 90 watts aggregate for all the ports. You plug one device in and it worked great. And as they started to plug more devices in, they couldn't get power. So the other thing that happens is somebody replaces a patch cord in that wiring closet with an inferior patch cord, and so you can rule that out. If the switch looks good, then you go, oh, wait a minute, what's this patch cord? And you look at it, and it's maybe some people may remember the old silver satin patch cords, the 8-conductor silver satin. I've seen people put those in networks. It's not pretty.
Yeah,
But, well, I think we're run over a little bit. So appreciate everybody who has tuned in today, and thank you, James, very much for being a special guest. Thanks for hosting us here. This is a fantastic facility. If you're not aware of Mayflex, go out and check them out. What's the website?
It's www.mayflex.com.
Perfect. Just go check them out. Lots to see there. Thank you, everybody, for your time, and we will see you in a couple of weeks on our next Tech Talk.
Thanks very much.